So as I mentioned previously, we have two types of fast Fourier transform. The first type is the decimation in frequency, DIF, and the second type is decimation in time, DIT. This is the difference of two types here. I suggest you just memorize one types, and for the other types, we just need to know what is the difference of these two types, and then you can have the idea how can we get the DIT. So before we go to the difference, first we need to see the labels of the graphical here. So first, at the left side here is our discrete signal, xn. The same for the DIT. At the left side we have the discrete signal, and then for the right side we have the discrete Fourier transform, okay, at the right side. And then how many separation here? It depends on the number of stage, which is the stage can be calculated by using this equation. Okay, the number of sample equals to 2 to the power of number of stage. How can we draw this x sign, or we also refer the x figure here as the butterfly, okay? And then the location of weight depends on our method, whether it is DIF or DIT. This part is how we can calculate the weight. I will explain in detail after this. Okay. Alright, so this is the general label of the fast Fourier transform. Next is we will see in detail. So when the question asks you to calculate by using the fast Fourier transform, you need to determine the number of sample. So for example, here we have number of sample equals to 4. Okay, so 4 equals to 2 to the power of m. We need to find the number of stage for our given number of sample. So in this case, we have 2 stages. Okay. Next is we need to know, or we need to find the number of k. So k refer to 2 to the power of I. Okay. In DIF, we will use the highest I. So I refer to this one from 1 until m. We can have 2 to the power of highest I, which is 2. 2 to the power of 2 is equal to 4. And then 2 to the power of 1, we have 2. Okay. Why the k value is important? Because we want to find the pair. What does the pair means? For example, here we have the first point here. We will have a pairing with another point. So this is the first difference compared to the DIT. For DIT, we will use I with the lowest value from 1 until m. So 1 is the lowest. We will get 2 to the power of 1 equals to 2. And then 2 to the power of 2, we have 4. Okay. So next is, the second difference is how we arrange the binary number, which the binary number will represent the n here. Okay. For the DIF, we will arrange the binary in ascending number. So for example, 0, 0, 0, 1, 1, 0, 1, 1. Okay. And then for the XDFTK, it is the reverse value of binary number. So for reverse value 0, 0, we will have 0, 0. The reverse value of 0, 1, we will get 1, 0. And then the reverse value of 1, 0, we will get 0, 1. And lastly, for 1, 1, there's no change like the 0, 0. Okay. Then you can transform the binary into the decimal. where 0, 0 is equal to 0, 0, 1 equals to 1, 1, 0 is equal to 2, and 1, 1 equals to 3. Okay, the same for the DFT. We need to transform the binary into the decimal value. So next is how can we make the pairing here, the points. As I mentioned previously, the K value is important for pairing. So for example, we have 0, 0 is 0 at discrete signal 0. The pair is 0 plus, this one we have 4 divided by 2, which is equals to 2. Okay, 2 plus 0 is 2. Next is we have 1. So 1 plus 4 divided by 2, we will have 3. So this is 0.1, or will be paired with x3. Okay, so this is why we need to know about K, because we will need to do the pairing of the points of even and odd index. Next is at stage 2. Okay, at stage 2, we have this one K equals to 4, this one K equals to 2. For example, we have x0 here, the first point. The pair of x0 will be 0 plus 2 divided by 2, which is 1. Okay, so 0 will be paired with x1. Okay, how about x2? So 2 plus 2 divided by 2, we will get 3. So 2 will be coupled or will be paired with x3. Okay, so this is how we find the pairing of the butterfly shape here. Okay, so for the DIF, we arrange the discrete signal in ascending number. As for the DIT, we will arrange the binary in ascending order at the DFT side. Okay, you can see here 0, 0, 0, 1, 1, 0, 1, 1. And for the DIT, the discrete signal will have the folding binary number of DFT. Okay, so this is the second difference. Okay, for the stage here, so when we calculate the number of stage m equals to 2, we will have 2 stage. Okay, we will have 2 stage. If we have number of sample equals to 8, 2 to the power of 3, so the stage will be 3. You will divide this part into 3 parts. Alright, so next is, okay, how can we calculate the weight by using this equation. The value of W at the numerator here. So first, we need to use the P. Okay, P equals to 2 to the power of M minus I. Okay, M is the number of stage, and I refer to the specific stage that we want to calculate. So for example here, at this part, we will have I equals to 1. So P equals to 2 to the power of 2 minus 1, where we will get 2 to the power of 1 equals to 2. Okay, next is Q. So what is the value of Q? Q is equal to the list number from 0 until P minus 1. Okay, since we have P equals to 2, Q will be equals to 0, 1. Not included the 2 value here. Next is T. T equals to 2 to the power of I minus 1 multiplied with Q. So in this case, we have I equals to 1. 1 minus 1 is 0. 2 to the power of 0 is 1. So T will be equals to Q. So T1 is equal to 0. T2 is equal to 1. Okay. And T is referred to WT, where we will have W0. You can see previous slide how we can calculate W0 and W1. Okay, so W0 equals to 1, W1 equals to negative J. Okay, next is at specific stage I equals to 2. We will have number of stages equals to 2 minus at the specific stage, which is equal to 2. 2 to the power of 2 minus 2 equals to 2 to the power of 0, where we will get the value of 1. So our Q is until P minus 1. Therefore, our Q will be equals to 0 only. The Q will be used for the T. T equals to 2I minus 1. In our case here, I is equal to 2. 2 minus 1 is 1. 2 to the power of 1 is 2 to Q. Since our Q is equal to 0, so 2 times 0 we will get 0. That's why our weight for the second stage will be W0 for both butterfly. Okay, so for the DIF, the difference is the equation to calculate the P and T. Okay, you can see the difference here. For the DIF, the equation is P equals to 2 to the power of M minus I. As for the decimation in time DIT, the P is equal to 2 to the power of I minus 1. Okay, the same for the T equation. DIF, in DIF, the T equals to 2 to the power of I minus 1 multiplied with Q. However, for the T in the DIT will be equals to 2 to the power of M minus I multiplied with Q. Okay, so for this part you can try by yourself, referring to my explanation for the DIF method. Okay, so this is the third difference. Okay, the last difference is where is the location of weight. Okay, so how can we get this equation x plus y and x minus y multiplied with the weight? Actually, you just need to memorize the figure of the butterfly. And as for the DIF, our weight is at the lower part of right side. Okay, so how can we get this value? So this one x, we go to the middle. Okay, and y we will also go to the middle. The operation between these two variables at the upper side will be plus. Okay, so x plus y and then at the lower side the operation between these two variables will be negative or minus. So here we have x minus y, and all these x minus y will be multiplied with our weight. So next, how we can get the equation at the DIT side. And as I mentioned previously, we just need to memorize the location of the weight. Okay, for example here we have x going to the middle, and then for the w will be multiplied with the weight before going to the center. So y multiply with the weight. Okay, so the operation between these two variables at the upper side will be plus. So x plus ywt, and then for the lower side we have x minus ywt. Okay, so it is easy to derive it without memorize the equation.